Hi, we are group 8 and myself Chandan and my teammates are Sawmya and Aishak. This is our embedded project. We named it as Smart CAN for safety with IoT. So we have 3 CAN nodes. This is our node 1 with Mega, and this is our Raspberry Pi which has CAN on it, and this is our node 2 with Uno. So this is our CAN node 1. It has components such as Mega board, and we are using Spark Fun CAN shield, and we are using 7 segment LED, 7 color and RGB LED, and a keypad. And this fan is to represent our climate control, and this fan is to represent our engine moving, and this is a 20 cross 4 I2C LCD. We are using it for a specific reason that we don't have much pins in our CAN shield to be spared. So this particular shield uses just 4 wires, and that is node 1. Coming to our Raspberry Pi node, here we have a Raspberry Pi camera, and this is our CAN shield of the Raspberry Pi, and we have Raspberry Pi in the down, and this is our Wi-Fi module, and this is the CAN bus that's going to the next node. And node 1 and Raspberry Pi is connected through single strand wire. And coming to node 2, that we are using just Uno board with SparkFun on it, and it has 16 cross 2 LCD and DHT11 temperature sensor and a sonar sensor. This is our node 1, which sends an empty frame with CAN ID 65 that will be sent through to the CAN bus. The Raspberry Pi picks up this CAN ID of 65 and update it to internet through Wi-Fi. So as you can see, the value 44, that field sends a temperature, and this field sends humidity. So we can see that 44 and 0 is sent to server, and a reply is given from the server as 200 OK. And we can see in our computer, in the website of ThinkSpeak, the temperature is value updated. Now, since the node 2 is not active, no sensor value is present in the bus. This is just a random value. Now, I'll be connecting my node 2, which has the temperature sensor, and Raspberry Pi picks up there is some kind of data present, and we can see here it is received data, and that will be updated in the CAN bus, and received a CAN ID from node 2 as 9, that is the received CAN is 19, and then the similar update will be sent to internet 27 and 30. And here, as we can see, the temperature is updated 6 to 9, and the time on the computer is also same, and similarly for humidity it's updated. Now I'll increase some temperature by holding it. The humidity increases to 53% and temperature 2. This will be sent to our node 1. As you can see, 68 is coming up, 67, it's keep on changing. And there's an update right here too. 64. Coming to next part of our project, that is face detection. This is our Raspberry Pi, and we have a camera. As you can see, the Raspberry Pi is picking up the sensor values and updating into the internet. But in the meanwhile, we want it to do face recognition. So if we press this button 1, it sends out a message 16 in the fifth bit of the CAN message 65. There you see that, and then as soon as Raspberry Pi sends that 16, it goes to face detection and the training data will start loading. As you could see, it detected as Chandan, and we received a message Chandan is driving. Similarly, when a face is not detected, the Raspberry Pi will send out a message. Now, Sawmya is gonna do it for face detection because she is not in the database. So it is throwing an error showing the face is not detected, and an alert user not, and it sends out a message and a call to the owner. Since we are not by this website, we cannot put a custom message. Received a message. Volt stolen. Five. Now to demonstrate the working of DHT11 sensor that is connected on node 2 and a fan that is connected on node 1. Now Aisha here will increase the temperature and we will wait until it reaches 31. As soon as it reaches 31, it'll turn on the fan. As you can see, it's receiving the temperature that is changed. So it is 30 or on the side. It is received 30 here, and it will increase more to 31, and it is updated to 65 as you just saw, and the fan turned on. To cool off the temperature, we are just using an ice. As you can see, the humidity also drops below 24, so the fan still keeps on. So she took out the ice, so the humidity is back to normal. It's increasing. Correspondingly, these temperatures are sent to Internet of Things, to our website. As you can see, there's the latest update there and latest humidity update right here. Previously, as DHT11 sensor was controlling the temperature by turning on the fan, now we'll show how our sonar sensor works. On node 1, we have a fan that indicates our engine running, and we have a keypad. Right now, the distance between the sensor and the keyboard is shown as 13, that is in the third bit. It is sent through node 2 as a in the CAN message as 19 with a CAN ID of 19, as you can see. Yeah. If Soumya keeps her hand closer to the subject less than 4 centimeters, there is a red light that indicates the user that you are too close to the wall or another vehicle. Now, if the person is putting the car into a reverse gear, say I have turned on the fan, this indicates the engine running. Now it's glowing green, showing that it is also safer distance. Now as Soumya puts her hand closer, as the distance is 5 to 4, if the distance is 5, it's blue, and if it's more closer, it turns off the fan. That means it's turning off the engine. And that demonstrates our sonar sensor. Take one. This is a Raspberry Pi, and we are right now training the Raspberry Pi to detect faces. So the training process starts now. We are running the Python code to capture the positives. So it's ready for capturing the images. Now Ishak here will be ready to cap with the camera. So found, it says face found, and it's stored as positive user 1. In the directory. This is how it will be stored inside Raspberry Pi.